All right, good afternoon. This is Lafayette High School Functions Trig, and we are learning to match equations with graphs. This is number 4 of your practice review, and this is a cosecant curve that we have to match up. And a lot of students, I notice y'all, lots of detail, going through that t-table and doing your transformations and stuff like that. It's not wrong, but I just want to show you a much quicker, faster way to do this. The first thing I look at, okay, we know what a general shape of a cosecant is. We know a general shape of a secant, a general shape of a tangent, cotangent, all of our functions that we know that just by these upside down and right side up U's, it's got to be either some sort of cosecant or some sort of secant thing. Nearly where I always start on anything I'm trying to match the graph with is the number one thing I like to look at is my vertical shift. Where's my neutral axis? This is going to help us scratch a lot of trash. So what I'm going to do is each one of these, I'm just going to plot where this neutral axis is supposed to be. And how do I know it's a neutral axis? Okay, look over here that this distance and this distance, all right? The bottom of my bumps and the top of my bumps, bottom of my dips are the same distance or amplitude away from the neutral axis. So really, without hardly doing a lick of work, we can eliminate D. Okay, so the next thing I like to look at is if I have a vertical stretch, which this one doesn't. So it's just going to be up 1 unit from the neutral axis, down 1 unit from the neutral axis. So that doesn't help me. So the next thing I'm going to look at that I think is going to help me is my horizontal compression. Okay, now I know since this is a 2, I have to divide all of my x's. That's going to squish my period. And I'm also going to look at the fact that a cosecant is the inverse of a sine. Now what this is going to do, that period of pi instead of 2 pi, it's going to make all of these scales, if you look, all these scales are the same. They go from negative pi over 2 to 3 pi over 2. And so it should look squishy. Which tells me that B does not look squishy. It looks kind of stretched out, if anything else. So I'm kind of thinking that B is not going to fit my profile here. Now, if I have a cosecant or a secant function, it's hard for me personally to kind of visualize where the periods start and they begin, because I have these asymptotes and bumps or dips and dips or bumps. So I know that the cosecant is the inverse of the sine function. So that means everywhere I see a dip, it's going to be a bump of the sine function. Wherever I see a bump in the cosecant function, it's going to be a dip in the sine function. So what I'm going to do here is I'm going to go along and I'm going to start trying to kind of sketch sine curves in here to match my cosecant curve. And I know that wherever I cross the neutral point, I'm going to get an asymptote. That's why I've drawn asymptotes, where you see here and here and here. So there's my bumps matching the dips, dips matching the bumps, and so on and so forth. And I'm going to do that for each one of my curves. It's going to give me a good idea of what the period is going to look like. And let's look at this guy over here. I know my period is supposed to be pi, and look at the period of my sine function here. This is way too big. I'm going to scratch that. Look where my function starts. It starts here and ends up here. Okay, so there is one period of my cosecant function, and look at this asymptote. It's way out here, much bigger than pi. All right, so choice B is out of the running. Now we're in between A and C. Okay, so let's go on, and I'm going to do the same thing here. And I see A and C are very, very similar. So I'm going to sketch in my asymptotes. I see that's got a period of pi. And that's looking like a possibility. Everything is kind of lining up, so to speak. So what is the difference between A and C? And I don't see a whole lot. So what I'm going to do now is, last but not least, let's take a look at this phase shift. Look where this curve is starting. It's not starting quite at pi over 4. It looks like it's starting more like pi over 8, whereas this guy down here, that's pretty obvious on choice C. That definitely looks like that asymptote is starting right there at pi over 4. So let's take a look at my phase shift and see where it's supposed to start. And my phase shift is C over B. I do the math. I get a positive pi over 8. So that means that's a shift left. So now that is how I chose between A and C. And I hope you find this a lot more useful, kind of a scratch the trash method, rather than just sitting down with the T-table. Not wrong, but kind of augments and saves a lot of work. So hope you find this helpful.